Okay, so let me do the quick review on the previous chapter, previous section, because we had a problem with recording. So just give me a second. Okay, so we started to talk about the relational data model, and we talked about different, first started how the relational data model started by Cott at 1970, and then we talked about the different part of the relations, which started with the relation definition, which was the table that we mentioned. So it's a normal table, 2x2 table, that you need to have the attribute on it. The attribute was the features for each of those entity, and we said the order doesn't matter, but the column name should be unique. And then we talked the domain. For example, for the course number, the domains are number. For the department names, it's the alphabet, it's a string. Also, for example, here for the first name is a string, but the domain are different. And then we talk about the tuple. So tuple was the each row in the table that technically it's a new record of data. Whenever we insert a new record of data, it's going to be a tuple for us. And then we talk about the null values, which null value, it means we don't have access to the information. That's it. It doesn't mean that's a zero or something. It just means that we don't have access to it. We don't know about it. And then we talk about how we can write it in English. So we said, okay, table name, parentheses, attributes, and close the parentheses. And if it's a key on it, you need to underline that specific attribute. So for example, here, the course ID is the key for this table. And we talked about the key and different type of keys. So we mentioned that each table needs to have a unique identifier. So technically, sometimes it's going to be more than one. So that's why we call all of those keys as a candidate, okay? But at the end, you need to choose just one as the primary key. And from now on, whenever we say key, it means primary key, not the candidate key. And then we talked about composite key. We had some confusion about the composite key. Again, just you asked the other day, the answer was correct. It was right. So whenever we have the composite key, both of them should be not a primary key. I mean, both of them cannot be a primary key. So for example, the example we had that the student ID and the first name, and you mentioned the student ID first name together with a composite key. No, it's not, because a student ID alone can be a primary key. For being a composite key, both of the items, they shouldn't be a primary key. And for the surrogate key and external key, we mentioned those type of key that for the surrogate key, they do not have any meaning outside of the system. They will automatically create it. External key, they have a meaning outside of the system, like the social security number. And we talked about the foreign key, which is a type of key that's technically is the main key, is the primary key in another table. So the only way that you can connect two tables together is through the primary key and the foreign key. So for example, here as an example, we have the course ID here. So this course ID is the foreign key for the course table, and the student ID is the foreign key for the student table. And we had this example, and then we talked about the two different constraints. So the first one, integrity constraint. The second one, referential. So integrity was just related to the primary key. So it means you cannot have a null value for the primary key. Otherwise, you will violate this integrity rule. So, and it's obvious, because if you don't have the primary key value for the primary key, so how would you define, identify that specific row or data or tuple? And then for the referential integrity, we mentioned this one is related just to the foreign key. And the foreign key can be null, or it should be related to an actual value in the reference table. For example, here, we said that the course ID 8, which I made a mistake when I first told you about it, course ID 8 here, we can see that the course ID 8 is not available here. So it means we are violating that referential integrity rule. Okay, so do you have any question regarding the last session material? All good? Okay, so let's start about the normalization. And just stay with me in the next hour because this is a really, really, really important concept that you need to learn. Because whenever you want to design the whatever database, you always have to make sure that you are designing a normalized database. And it has at least 3 conditions, which we will cover today. So by normalization, we just started a little last session about it. And if you remember, when we started the chapter 2, so we started with this simplified cell table that was just the only one table with multiple attributes name, column name. And we just started with that one because we just wanted to work on one single table in order to learn some initial queries for the SQL. But then we talked how this one could be problematic for us if we just have one table in the data set. Data redundancy, data inconsistency, and all of the issue that can happen when you just have it as a one table. As an example, we mentioned that, for example, in a sale table, if I, as a Hossein, my ID, customer ID is 1, and then I purchase some items. And again, next week, my ID again purchase another items. And again, in the whole year, for example, I purchased, I don't know, 200 times from the organization. So each time they have to insert my name as a Hossein, last name, first name, Mohit, last name, address, everything. So 200 times they are just importing my name into the system. And if sometimes, which is possible, some error happen, it's gonna be a disaster for a very huge data set, okay? So then we talked about it, that in this case, that would be a good idea if we just have a one customer table. And for number 1, just put my name and the address. And this time we are just recording my name in this dataset just once, not 200 times. So save time, save money, save energy, save everything. Save storage in the device that we have. And then whenever we want to work on the sale table, it just need to have my customer ID. That's it, just number 1. And then with the queries, we learn how to join this table together, okay? So that's the normalization process, okay? But in order to have the normalized table, we should meet 3 standards at least. I am naming them standards, but the name is not standard. The name is first normal form, second normal form, and the third normal form. So in order to have a normalized data sets and database, we should be in the third normal form level. So we will learn together today how we can have it. Okay, so before going through that step, we need to learn one concept, which we call it as a functional dependency. You give me the answer. If I have a sale table, okay, I give you a sale table like the one here, sale table with the sale ID, sale date, customer ID, product ID, quantity, tax, whatever, okay? So if you have the sale ID like 2 in the table, which of these attributes you can say, okay, I know these attributes based on this sale ID? Technically, for example, this is a table, the sale ID is 2. So technically, you can have access to all of these. Am I right? So if you know that the sale ID is 2, so you can say, okay, the sale date is 2. The sale date is November that date. The customer ID is blah, blah, product ID, blah, blah, and then. But if I just give you a sale date, February 2nd, 2024, can you exactly tell me which row it is? Can you? Imagine you have an organization that has 1,000 of the rows of the sale date for per day. So you can't, okay? So in this case, we have a definition here as a functional dependency. So in this case, in this table, I can say that the sale ID determine some of all of these factors, and these factors are dependent to this sale ID. So we call this one as a functional dependency. So by functional dependency, it means, let me read it from the text, a relationship between columns where the value in one or more columns determines the value of another column. So you will see in the database schema as a FD, functional dependency, manufacturer ID, the arrow manufacturer states. So in this case, we can say that the manufacturer ID determine manufacturer states. So whatever is in the left considered as a determinant. And this is a really important point. So just keep it in your mind, because for the second, third normal form, we will just work on these two words concepts, functional dependency. So one more time, functional dependency, it means if you have the left side, just simple, easy. If you have the left side, you can determine the value of the right side. And technically, X can determine Y, and Y is dependent on X. Okay, so that means the functional dependency. Okay, so is it clear what is the functional dependency? Clear? Good. So as I mentioned, in order to have the normalized data set, you should meet 3 standards. You should be in the third one, which the first one, first normal form, we will talk about them in detail. Then the second normal form, then the third normal form. So if your table categorized as a third normal form, at least you can say you have the normalized table. There are other normal form as well, but for having the basic standard, you should be in the third level. It's maybe a little vague, but when I tell you, you will see how much this one is easy. So let's start with the first normal form. Very, very simple rule. Just in a very simple word, you cannot have multiple value in one tuple, in one specific cell for the column. So right now you can see that the employee name is John, and the skills are programming and query optimization. Okay, so this is the first violation of the first normal form. So that's easy. So you cannot have two values for a specific attributes in that specific tuple, or a specific column in that specific row. Okay, so simple. If you see a table that has multiple values in one of the table cell, it means that the first normal form is violated. Easy. So in this case, for example, for solving this issue, we can have another table that, for example, John as an employee name. And for example, let's assume the ID for the John is 100. So John 100 programming, John 100 query optimization. So you need to divide this one to the two different cell. So that's the first normal form. Okay. So just one of you tell me, what is the first normal form? How we can violate this rule? Yes. Under one attribute, that's it. If we have more than one values under one of these attribute names or column, you definitely violated this rule. So technically, we can say that all the attributes value must be atomic. So that's a first normal form. But for the second normal, this one is also so easy. So what was the composite key? Yes, for example, we had a student ID and course ID for that table that we call it course in grade and the grade here. So because in this example, a student ID alone cannot be a unique identifier because we can have one student with multiple course and we can have one course with multiple students. So in this table, a specific table, a student ID is not a unique identifier. Also, course ID alone is not a unique identifier as well. So one more time, the combination of these two can be considered as a unique identifier for this table. Is it clear? Now, here we have the composite key. So whenever we have the composite key in a table, now it's time to remember the functional dependency that we have. Whatever attributes that we have, A, B, C, D, okay? Okay, so a non-key attribute, A, B, C, D is a non-key attribute. So the key attribute here is just a student ID and course ID. A non-key attribute can be functionally dependent on only part of the key. So if, for example, the grade by itself is just dependent to the course ID, but not to the student ID, in this case, we are violating second normal form. Okay, so one more time. Just keep the composite key on the side. Whatever non-key attribute, whatever attribute that are not key, okay, if they are dependent, they should be dependent to both of them, not just one of them. Cannot be just dependent to just one of these key. It should be definitely dependent to the both key. And if you remember, when we had this example, the sale ID, sale date customer, we mentioned that sale ID, since this is the primary key here, it's the determinant for all of these columns, which means all of these attributes are dependent to this one. Am I right? Now, instead of sale ID, we have two ID. We have two key, which we considered as a primary key. So in this case, all of these columns should be dependent to each of these two, not to just one of them. If it's just dependent in one of them, it's going to be a violation. Let's see this example. We have a student ID, we have course ID, a student name, credit hours, grade. Am I right? So we can all confirm that the student ID and course ID are the composite key. Yes? So right now, a student name. If I have the student name, a student name is dependent is to just a student ID, not the course ID. Okay? So now, right now, we can say there is a violation, because if it was supposed to not have a violation, this student name should be dependent to both of these attributes. Okay? But right now, it's just dependent to one of them. So that's the violation of the second normal form. So in this case, as an issue, we would have the data redundancy, all the anomalies by updating, deleting, and inserting the table. So in this case, we have to decompose the table, which we call this action decomposition. So we have to decompose this table to these three tables. So it's better to have just one table for the student ID and the student name, have the course ID and a student name, and a student ID, course ID, and grade. So that's we call a normalization. Now we have the database that we just decompose the table to the 3 different tables. Now we have the normalized data sets for the second standard level or the second normal form. Yes. Okay, some typos here, student. Let me, yeah, that's the correct object. Yes, you're right. Yeah. You're right. So that's the part that we technically divide our table to 3 different tables in order to normalize the data sets. Okay. So right now for each table, we have a primary key here, a student ID, course ID, and here we have the composite key, a student ID and the course ID together. So that's the second normal form. And when we see the example, the assignment, we will go through some of them and then we can again work together on this assignment. So the third one, which technically is the most important one, why? Because if you design your table that meets this standard level, it will automatically meet this first level and the second level as well. So if you just make sure that your table, your data set is on the third normal form, it means you are good to go for the database. But what does it mean by the third normal form? Now, let me one more time review the functional dependency. So X, Y. Read it for me. X determine Y. Am I right? That's a functional dependency. So when I have the X sale ID, for example, I can have all the related information for the other attributes. And we can say Y is dependent to the X. Simple. If you want to be in a third level, third normal form, this X should be always a primary key. That's all. Which means if 2 non-primary key, for example, 2 non-key attributes, for example, here we have X, Y, let me see if I have a table here. As we see here, we have the employee ID, okay? Employee name, department ID, and department name, okay? That's the table we call employee. Now, we can see here, employee ID is the primary key in this table. But the point is, we can find that there is a functional dependency between the department name and department ID as well. So that's the violation of the third normal form. So it means whatever functional dependency that is in the table, all of them, the left side should always be a primary key. So you should not find any other 2 attributes that are not primary key and they have a functional dependency together. So as an example that we have here, so here we have the employee ID, skill type, and bonus. Okay, so there is a functional dependency here. Employee ID as the primary key in the left side, and it is primary key, check. Determine the skill type and bonus. So far, good. But here also, when you have the skill type, you can determine the bonus rate as well. So technically, a skill type determine the bonus level as well in this organization. So since the skill type, which is on the left side, is not the primary key, we have the violation of the third normal form. So one more time, we can see here. So employee ID, skill type, bonus rate. So in order to have the solution, we need to decompose this table to two different tables. The first one, just the employee that has the employee ID and skill type, and then the skill table, which is the skill type and bonus rate. Here, the example would make more sense for you because it's in table. Employee ID, employee name, department ID, department name. So what is the primary key here one more time? Employee ID is a department key. Okay. So if I have the employee ID, I can determine the employee name, department ID name, and also department name. But the point is, there is another relationship here between the department name and department ID. So technically, we have another relationship that none of them, either of them, is not a primary key. So technically, two non-key attributes are having some connection together. So technically, that's the violation of the third normal form. So this is the very important sentence. So if you always design your table based on these three sentences, you will be fine. So let's read it together. All attributes in one table. All attributes. So let me. Okay, so this is the primary key X. All attributes in one table. Y, Z, W. Okay, they must depend on the key, which is X here. Nothing but the key. So you cannot have W to Z or Z to Y. So it's forbidden. And just only, nothing but the key, only the key. So whatever attributes you have in a table, they all need to be just dependent to the key, only key, and nothing but the key. Okay, so that's the easiest way to design a table that you will make sure, okay, now we are in the third normal form. Are you sure that all is clear regarding the third normal form? So we will see in the assignment that we will go together for some of them. So technically, if a table is in a third normal form, technically we are good to go. So whatever we do after that, it's for having a better data set, having a better table, better relationships, and also in order to again reduce the data inconsistency and also data redundancy. So the fourth one, we have fifth, sixth, but technically no one cares about those anymore. So the other one is the fourth normal form. Technically, when a table is in a third normal form and we don't have any multi-value dependency, we can say we are in a third normal form. Okay? So here, there is a table, faculty table. This is the first name, committee, and the course. Okay? So we can see here that, for example, for the Jones, he is a part of, or she, I don't know. They are part of the different committee, admission, scholarship, and also different course numbers. So here we have a one combination, Jones admission, IM 101, Jones scholarship, IM 101. Again, Jones admission, IM 102, and the rest. So here, technically, we have multi-value dependency. So in this case, easiest way, again, is to just divide these to two different tables. The first one, just the faculty committee table, which is the Jones, that's part of the two different committee, admissions and scholarship, and then the faculty and the related course. So here, the first name here is the primary key, is the foreign key for this table, and vice versa. So you can just connect these two tables together. So technically, if a table is in a third normal form, and also there is no multi-value dependency, you are in the fourth level as well. That's it. That's the only difference. But the most important one, again, it's always the third normal form. If you design your table in a way that is totally created based on the third normal form, you are good to go. Let's have one more time this sentence. All attributes in one table must depend on the key, all of them, just on the key. The whole key, if we have the composite key, it should be dependent to the both of them. Or if it's a three-part, all of the three. And nothing but the key. That's it. That's the easy rule that you can just remember and apply on your table database. So do you have any question at this moment, or do you want me to go through some of the assignments, and then we can have okay, so in chapter 3, you have two assignments, 3.1 and 3.2. So let us start with the first one has 25 questions. We will go through the first three together, okay? So this is the assignment 3.1, functional dependency, okay? In the abstract table, capital letters are attribute name, okay? And lowercase letter and numbers are the values. So attribute A, attribute B, C, D, E, and the tuples value are A1, A3, A1, A2, and whatever. Okay, so that's the table. So true or false, column A determine column B. So let me tell you, in order to, again, one more time, to have this connection, which X determine Y, all of the value in the X, technically, they should uniquely have an equivalent value in the Y. So do you think the first one is true or false? So false Y, true Y. So which one? The 2A1, it doesn't matter, it's not a problem. We can have, that's the point. So here, the A1 is equal to B2, okay? Also, here we can see A1 is also equal to B3. Consider it as a sale table, which customer ID is 1, Hossein, Mohit. And then you have a table that my customer ID appear twice, which is 1, 1. Once is Hossein Mohit, the other one, your name, I forgot. Yes. Okay? Sorry. So you see, now we have one value, okay, that technically determines two different value, which is wrong. So technically, this is the false. Am I right? The S was right. Am I right? C. Spell it for me. I want to learn. C. Y. That's it. Oh, cool. Okay. So is it clear why this one is false? Yes. Yes. Now the second one. column A determine column C? Can column A determine column C or can't? So for A1, we have C1. For A3, we have C3. For A1, technically we should have A1, which, sorry, C1, which we have C1. And for A2, we have C1. So for whatever value here, we have unique value here. So it means column A can determine column C. Yes? And again, the sad point is next semester, again, our class, in my class, is gonna be again at the 3:30 to 4:45. So it's normal for you to just be a little sleepy. So I don't know, whatever class that I've ever taught so far, all of them is always afternoon. All of them, 2, 3, 4. I don't know what's the right schedule, but yeah, that's fine. So let me go through the third one. Column A determine column D. A to D. You tell me. Just you need to do what I did it. Okay. So A to D. What was it? A to D. Okay. A1 determine D3. A3 determine D2. So far, so good. A1 shouldn't be D3. A1 is D1. And A2 is D4. Let me check one more time. A to D. A1 to D3. A3 to D2. A1 to D1. A2 to D4. So technically, all of them are uniquely contribute a table, another, what is it, value. So we don't have, for example, no, wait, no, you said it's false, sorry. Yeah. A1 has to be, is it twice. So A1, it's a D3 and D1. Sorry, my bad. So technically, again, that's the issue. My ID, customer ID, Hossein Mohit should be just always Hossein Mohit, not once Hossein Mohit, one sign. Okay, so that's the false. And you need to do the rest like this. All good? No? One more. Okay, which one? All of them. Let me start from the first one. Okay, so that's I like it, honestly. If I just tell something and you all say, okay, that's the. Let me go with this example. My customer ID, okay? My customer ID is 1. This is not 1. 1, okay? And my first name, Hossein, my last name, Mohit, the address, Marietta, whatever, okay? Now I have Hossein assigned to customer ID 1. And now if I have customer ID 1 and go to this table, I can determine these values. Am I right? Am I right? But if you just have the Hossein, okay? Can you determine other values? Maybe there are multiple Hossein here. Okay, maybe there's another Hossein, L, the last name, whatever, and the ID is 2. If I give you the Hossein, just the Hossein, you cannot determine which row it is. Am I right? So right now, but when I just give you this one, you can definitely determine the rest. So that's the functional dependency. It means by having just the number 1 as a customer ID, by having just this X, you can determine all of these Ys, all of these columns. Okay, so that's the functional dependency. That's this definition. So when we say one column, one attribute, determine another column, which means for whatever value for that specific column, it should be a unique value for the other ones. So how this one would be violated? You know that right now one is Hossein Mohit. If I have another one here, technically you expect to have Hossein Mohit. But if you see Sai, that's the error. So technically, in this case, we can't claim that the customer ID is determining the, for example, first name or whatever attribute that we have. So here, in this case, we are asking column A determine column B. So I expect to have a unique value for whatever value is in the column A on column B. Right now, for column A, the value is A1. A shows, you tell me, B2. The other one, A3. It shows B2. Customer ID 1 is Hossein. Customer ID 2 is also Hossein. It is fine. Am I right? But right now, we have another A1, which is customer ID 1, Hossein. And you expect to have Hossein, B2. But now you are seeing B3 or Sai name. That's the violation. So technically right now, for one unique value in column, whatever is it, for one unique value in column A, you have 2 different values. That's why we cannot say these 2 are determining each other. So another word, customer ID 1, which is just Hossein, right now is equal to Hossein and Sai. So that's the error. All agree? Yes? So for the true version, A to C, or the A to C version. Sorry? Yeah, it's right, yeah. So A to C. It means for whatever unique value in A, you should have a unique value in C. So right now, A1, you read it for me. C1, A3, C3. So far, so good. A1 should be C1. Customer ID 1 should be Hossein. Customer ID 1 is Hossein, which is C1 in this case. And the other one, A2, C1. It could be C3, it could be C4. It doesn't matter. Because for sure, there are a lot of customers with the same name. Okay, so that's it. And for the third one, that A to D. A1 is D3, okay. A3, D2, okay. A1 should be D3, but it's D2. A1 should be Hossein, but it's also Sai. So Hossein and Sai is the violation of the rule. Good? Good. So that's the 25 version, and you will see some more. So for example, taken together, column C and D form a possible primary key for the table X, and then you can do the rest. And this part, you need to identify a normal form, sorry. So it will give you a, yes. So what's the definition of the primary key? I don't want to answer to this question for the 11. I need you to do it, but I will just go through it. So the primary key, what is a primary key for the table? A unique identifier. Always tell this example, customer ID 1 is Hossein, 2 is Sai. Okay? So right now in this table with the rest of the information, this customer ID 1 uniquely tell you Hossein Mohit blah blah is the first customer, Sai the rest is the second customer. Since this specifically column can determine the rest of the values, technically it's the primary key. So if you have just my name in a 1 million rows of data, you cannot uniquely identify one specific row just with the Hossein or Sai name, can you? No, it's not possible because there might be 10,000 Hossein, 2 million Sai, for example. Maybe. Okay? But the point is, but if you have just one, you can't go there and find just the one because one is a primary key and it's just telling you Hossein the rest. Who is the rest? So for the, which one? $11. Oh, okay, okay. Column A is the possible primary key for the table X. You need to go through the column A and see if these values in column A, technically they are unique to identify the rest of the rows. So normal form. Just again, just think about this example and you can figure it out. If it's not unique, so technically it's not a primary. If it's unique, it's primary key. So this one, in these examples, in this assessment, they will give you this English version of the data table. So right now, this is the employee table. That employee ID is the key, is the primary key. Name, address, phone, skills are the other attributes, are the other column. And also they will tell you that, for example, in this specific case, there is a functional dependency. Phone can determine address. Okay? Now, for each of these, you need to tell what is the highest level of normal form. So let's do the first one together. Is it on the first normal form or not? For being on the first normal form, we mentioned we cannot have multiple valued for the attributes value in the specific table, a specific tuple or a specific rows. So we cannot see tables with the values here. But the book wants you to just determine. So for the employee ID, it's the key, primary key, and for sure, it cannot have multiple values. For the name, cannot have multiple values. Each person just have one name. Address cannot have. But for the phone, can we have multiple phone number? Because yeah, we have cell phone number, work number, because hey, it didn't mention exactly. That's the, I mean, intentionally the mistake in this question. And also for the skills, I can have multiple skills. Okay, so here, technically, this table is possible to have multiple values. So technically, this table is not in the first normal form. For the second normal form, can we say about the second normal form? No, because we don't have composite key. It's just one key. But the point is, the simple rule that just violated everything here. There is a functional dependency between two non-key attributes. And we mentioned for the functional dependency between A determine B, always the left should be a primary key. Here, phone is not a primary key. Address is also another non-primary key. So technically, there is a functional dependency. So also, the third normal form is not true. So technically, this one is a none of the above. It's not even in none of these normal form. The second one, you tell me. Just try to go through each of the attributes one by one. So the worker ID is the primary key here. Am I right? And it usually just have one value. Worker name, true. Maybe you just have a question right now. Okay, for worker name, maybe I as a person that entering data, maybe I by mistake import some different names, multiple names. That's a different thing. Here we are just considering the possibility to have different value. In a previous version, we could have multiple skills. That's why we said this table is not a good table for the one first normal form. But here, spouse SSN, unique. Spouse name, unique. So technically, this table can be in the first normal form. So far, so good. We don't have composite key here. So we don't check the second one. We just directly go to the third one. So for the third one, so spouse social security number can determine a spouse name. Am I right? Yes. So technically, we have a functional dependency that none of these are primary key, which technically we just want to have for the left one. So right now, in this example, the spouse name, okay, spouse SSN determine the spouse name, which is not a good point in the table. We mentioned that all the attributes should be dependent to the key, the whole key, and nothing but the key. It's looked like this or something. So one more time, all the attributes should be dependent on the key, whole key, nothing but the key. Here, this attributes, spouse name, is dependent to the spouse social security number. Am I right? So technically, we are violating the third normal form as well. So for this one, we can just technically say we can have the highest one, which is the second normal form. Let's see the third one. Okay, this one is good. We have date, customer, product. Okay, so technically we have a composite key here. Okay, vendor city, and sales representative. Also, there is a connection here. There is a relationship here. There is a functional dependency here. Customer determine the sales representative. As we mentioned, the left side should be primary key. Right now, it is primary key. But the point is, sale representative, for not violating the second normal form, it should, one more time, all the attributes should depend to the key, the whole key, nothing but the key. Right now, this one is dependent to the key, but it's not dependent to the whole key. It's just dependent to the one of these three, say representative. If we wanted to not violating the second normal form, this cell representative should be also dependent to the product and also to the date as well. But regarding the first one, date is the unique value, customer name is unique, product is unique, vendor city, sale representative, all of them, they can be unique. So this table technically is on the first normal form. Ask me a question, please. Is it clear why this one is in the first normal form? If not, tell me. Oh, the first, okay. We probably you just have the issue with the first normal form. Because again, and to be honest with you, you are right. You are right. But the point is, the book example, the book assessment, they also want you to consider this possibility that in the skills button, there is a possibility to have multiple values. That's it. Since there is a possibility to have multiple values for the skills, which we have the skills example in the book, so technically, because of that possibility, we can say this table can also be not in the first normal form. But for the second, for the third normal form, we can see there is a functional dependency. One more time, the rule. All of the non-key attributes should be dependent to the key, the whole key, and nothing but the key. To the key, the whole key, if it's a if it's all connected to the key, it's a first normal form. The whole key, which means if we have the composite one, so it means it depends on the both or all of the whatever part of the composite key. And nothing but the key. So technically, when you have all of the attributes just dependent to the primary key, you are in the third normal form level. Read the book, read the PowerPoints. After making sure that you understand the concept, then do the assignments. Good? Yes.